Hi, in this video we shall see how to run DRC. So again click on PVS, run DRC, and a form will open like this. Again you open the load preset, click on load presets, and then you select this file and click open. So this is the first time when you are doing this. Once you are done, you need not do this again and again. So um, only if no file appears here, you will click on this and load this. If it appears here the run directory, you need not load it again. Then you can just have a look at all these things and observe it carefully. uh, Everything is preset, everything is loaded from the preset file. Then you can simply click on submit. Now the DRC is running for you. So it says there is only one error. So it says uh, minimum M1 all area. So it is saying the area should be 0.006176. So now I have to see, it is saying area is less than 0.006176. So I need to make the area more. How can I make the area more? I can increase the length. So for that, what I will do is I will just take this path and I will start it from here. I will also increase it here. Keep it from end to end of the PR boundary. Similarly, I need not do this for here, but just I am doing it because if you have your input pin and the output pin running across the cell, it's easier to connect from outside, right? For that purpose, I am doing it, and there is no harm in doing this. So for that reason, I am doing that. Just save it and then run DRC. You can just rerun. So now you see there are no errors. So it means that you don't have any DRC error. Okay. So but that does not stop there. Actually, we have reduced a lot of area by this way, but still there are a lot of things that need to be observed carefully. So how about why do we need to keep our infit here only? Why can't we bring it further down? And why we need to have so much of gap in between this? And why we need to have this one here? Why can't we have this one somewhere near here? So we'll see, we'll try to reduce the height as much as possible. We have the width fixed, we can't go less than this, right? So we can actually move it a little bit like this. And I will start things from here. So instead of moving one by one everything like this, I will just undo. What I will do is I will select everything except and press Q. So I need not move boundary or I will just what I will do is select everything and just move it towards left. Press F. Now what I will do is enable partial select and then draw a selection box such that you cover only the PR boundary and metal. So press F. So in this way I have reduced my width a bit more than earlier. I will just keep this pin exactly inside the PR boundary aligned like this. I don't want my pin to be going out of the PR boundary. And now what I will do is I will try to have this metal as minimum distance from this as possible. Let me keep it somewhere here. And again I will also keep this somewhere here, and I will now um, run DRC. Before that I need to save, press F2. So yeah, it is saying that I need to have this via to LiPo spacing should be 0.024 micrometer. So just remember one thing, whatever the number it is showing, it is in terms of micrometer. So 24 nano, you have to measure it and move it upwards. So I think I'm not getting any error for this, so I can still move this metal further, right? So what it is saying is M1 to M1 spacing should be 32 nanometer. So that is the error here. I will measure. So to measure, you have to draw the scale. First, I will enable only metal one. So I will draw a scale from here and measure 32 nanometer. Press escape. Now I'll enable all layers. Select this metal and this wire also, and start moving such that it is exactly 32 nanometer away from that. Okay, so now press F2 to save and press Shift K to remove the scale. Now I will again this one also has to be 32 nanometer away, right? So I'll just keep it 32 nanometer away. Right, and press F2 and press Shift K to remove the scale and rerun DRC. Yeah, before rerunning DRC, you have to just save your layout. Save the changes that you have done to your layout. Then you have to do that. So what it is saying is, yeah, here I have my pin unmoved. I mean, I should have moved it here. I have forgotten that. And then there is a via. Uh, so it says 24 nanometer distance from this LiPo to this via should be there. So what I will do is I will measure 24 nanometer from there. To measure, before measuring, I'll just move this pin over there. Properly. Now I will press K to enter into the scale mode and press F3 for options. Now I have to draw this thing diagonally almost. So what I will do is click on none, snap target, and click on orthogonal any angle. Snap mode should be any angle and click hide. Now click on this point and then measure 24 nanometer. So now it is 22, right? So this is 24, or I should move it in this direction, or I should move it upwards. So I should move it there. Select entire thing and press M, move to move upwards, and then move like this. Press F and press F2. Now and press Shift K to remove all the scales, and now it will be clean. If I run DRC, now it will be clean, right? So I need not check that again, but before that I'll go do some changes over here, and I'll check the change on DRC if I'm getting any DRC errors over there. So I'll take that entire this thing and start moving it here. Press F2 and then rerun. So it says there is one error. Minimum annual spacing to active is 0.16 micrometer. So what it says is uh, my n well has to be away from the n plus active. This is my n plus active, right? N fed. So n well has to be away from n plus active by 0.16 micrometer. So I'll close this, just measure, press K, and from this active you measure 16, sorry, before that we had pressed any angle, right? So I'll make it orthogonal again because it will be easy to measure vertically, and press hide. Click on this and then press, you have to, oh, so 0.16 micrometer is 160 nanometer. So you have to move it till this point at least. So now select the entire thing like this and press M and start moving upward like this. So you can move it exactly here. So now you have a distance greater than 160 nanometer. It's 161 nanometer. So then press Shift K, press F. So now you can see um, how much height I was able to reduce. So I am actually increasing my area, decreasing my area. My layout is becoming more and more efficient in terms of area, right? So this is the way how you do how you reduce the area and make it your layout most optimized in terms of area. So again, I will need to rerun and make sure that there are no DRC error. So as you can see, there are no DRC error. Now I will reduce this PR boundary height. For that, I need to enable partial select, and I will draw a selection box such that it will select both PR boundary object and the PR boundary layer both, and I will start taking down like this and press F. So now you can see it is press F. It is properly now the area is height is from from this boundary to this boundary. This is my height, and So further, I can actually, there is some gap here. I can actually move it further left, right? So what I will do is press Shift K to remove all the scales. Press F and now entirely Control A, move it towards the origin like this. Again, uh, bring back your pin inside the PR boundary like this and stretch it like this. Metal, press F. So yeah, if I have to calculate my area of the cell, I will just switch off all the layers and press K and start measuring. So mm, height of the inverter cell is 528 nanometer and width is 478 nanometer. So your overall area is, you can just see here, 528 star 478. So it is 252 384 square nanometers. Okay, so in terms of micrometers, if I have to say, it's 0.528 cross 0.478 equals enter. So it's 252.252 approximately. It's 0.25 micrometer square. You can say that. Press F, and you need not have the scale always. You can just remove all the scale. Press Shift key to remove all the scales at once, and now you can see all the layers like this. And this is your inverter layout with optimized area. And since we have done so many changes to our layout, like in terms of DRC, and it's always good to run LVS and make sure that LVS is also clean at the end after DRC, after running all the DRCs, after getting DRC clean. Anyway, we had run LVS earlier also and it was clean, but now we have made so many changes. Of course, the connections were same, but it is also always recommended, once you make any changes, you run LVS and make sure that your LVS is also clean. And one more thing which I wanted to say is, here you can see there is this N well, right? This N well. I will just enable the N well. So there is this jack. So this should not happen. And how can I avoid it? I will just draw a rectangle here. So I will just draw a rectangle here like this. Press F. So this is my final layout. So on this I will run DRC once. Save the layout and run DRC and make sure you have your layout DRC clean. Yes, no errors are appearing. My layout is DRC clean, and I will close my previous DRC window. Now I will also run previous LVS. It has been already loaded, so I will just submit. So it is also LVS clean. Now I can say my layout is completed. It is most optimized, and it is LVS clean, and it is DRC clean. So now I can say I have done my layout properly. So that's all for this video. Thank you.